Okay, perfect. So we're ready to start. Hello, everyone, and welcome to our first 2023 episode of the Mining Experience. For those who are listening us for the first time, the Mining Experience is a live podcast that invites professionals from the mining industry to discuss new technologies, address challenges, and share, of course, work experience. I am Daniela Jaimes, Marketing Manager at ProMine, and here with me is my colleague Umaima. Hello, Uma.
Hello, Danny, and good afternoon, everyone. I'm Umaima Latris. I'm a Promise Account Executive for Canada, and I'm also a mining engineer. For today's episode, I will be your co-host. So on this occasion, we are going to talk about point clouds and why it is considered the visualization tool of the future. Today's episode is very exciting, not only because of the topic we will discuss, but also because we are having a very special guest that will share with us all his experience and knowledge on point clouds. We welcome Mr. Ivan Dion. Hello,
Hello.
Ivan.
Hello. Thank you for having me talking about point cloud. I hope that I'll be entertaining and also giving a lot of useful information to our listeners.
Thank you so much, Mr. Ivan. Well, I'm going to tell you more about Mr. Ivan. Mr. Ivan is president of the company ProMine Inc. that serves over 100 clients in countries around the globe. Mr. Ivan is a respected individual in the mining industry and has extensive experience in programming, surveying, underground mining, and CAD-based software. He has also experience in research, and he has worked at the Noranda Research Center at Point Claire, Quebec, Canada.
Thank you. Well, just before we start, I would like to remind our live audience that you can ask any question you want, either in the question sections on Zoom or in a comment if you are watching us live on YouTube. We will answer all the questions at the end of the podcast.
Thank you so much. Well, let's start by getting to know Mr. Ivan a bit better. Mr. Ivan, can you tell us what motivated you to work in the mining industry?
My father was working for a mining company. He was a mechanician at the Quebec Cartier Mining Company. So basically I had touches with the mining company. Of course, he wasn't working, let's say, at the mine per se, but I knew what mining was. When I grew up, basically, I kind of looked at all kinds of career, of course, and engineering was kind of my choice. My father being a mechanician, we did a lot of mechanical stuff at home, so in the garage and so on. So it looks like we always had old cars and old stuff that needed always something to fix. So I was looking at becoming a mechanical engineer at first. But when I got to the final choice, I would say, for to go to university, and I looked at what was actually doing a mechanical engineer and what was doing a mining engineer, I found it much more interesting, basically, a mining engineer, because for me, it was a way to see the world, basically, because, mining operations are all over the place. Yeah, and you will probably never spend your whole life into a mining operation because, they open, they close, and also you have opportunities to go elsewhere. And also mining engineering is very practical. It is very, you're handling rock, and basically you're using big equipment and all of that, and you need to optimize all of this. And this was talking to me more than spending time calculating mechanical stuff. And so I went to mining engineering because of that. So that was what guided me to go to mining engineering.
Wow, that's a great story, to be honest, and very inspiring to you. So I think that everyone that goes into the mining industry has like a different path to get there, but actually you're not the first person that I hear that starts on mining engineering because of their family and what their parents did and they were passionate about it. So it's a really nice story. Thank you so much for sharing it with us.
Yeah, thank you so much. I mean, that happens to me as well. I was just hearing my grandpa's stories about mine, and it was such a wonderful world for me to explore. Well, talking about this word, what type of mining are you actually familiar with, Mr. Ivan?
Mostly underground hard rock mining. The mining operation I've been, let's say, working with were mostly long hole and cut and fill hard rock mining. So that's smaller ore bodies in general. Of course, I worked a bit in open pit, and I had true pro mine opportunities. I would say I work with some underground coal mines and potash coal mines, a bit of block caving also in there. So I would say I touched most of the large, I would say, categories of mining. Of course, underground hard rock is where I have the most experience.
Perfect.
Thank you so
Makes
much.
sense.
Well, our next week question is, what experience do you have on surveying?
My first internship was in surveying in an open pit, large iron mines, basically. So that it was back in the days. It was not, I would say, robotized instruments that we were using. It was digital, but you had to write down the numbers into a field book. So that was kind of where I touched surveying. Then, well, I went into some other fields like ventilation and blasting for a while. And with ProMine, of course, it was very early in ProMine that I needed to do some surveying software. So I did some surveying software in there. So I've been developing survey software for 30 years now. Of course, I've seen all the changes from a survey book to a logging of points, sometimes with the data logger that was separate from the instrument, then the total station that came in and that computed all your point coordinates. And after that, the robotized instrument that will follow up your prism wherever you go. The GPS also happened into that time. So I've seen all of it. And of course, every time there is something new, I need to change the software in there. Whenever I visit a client, sometimes, I'll go on the ground and go, see in action what's going on. And like last year, I was at a client and we were on the ground looking at how we could improve our survey program with a surveyor. So it's kind of, I've been working with survey for a while. We do have survey instruments here. Well, if you could see in the office here, we have Prism hanging up on the walls, and we have survey instruments for testing all of that. So it's so I'm kind of, in touch with the the survey business every now and then.
Yes. Well, go ahead.
Yeah, no, I was going to say that it feels really special to be present and to can relate with all the processes of surveillance since the very beginning. And it's not the very beginning, but yeah, a lot had happened since then.
Oh yeah.
I totally. What I was going to say was just that I find very interesting how you have been able to see all the stages of like how technology has evolved to make processes more efficient and accurate, and all of these things that make all the operation easier, right?
Yeah. You build experience and knowledge through all of that, but sometimes it's kind of I would say you have that knowledge, but it's not going to be useful anymore. So you need to kind of, hey, push that aside, learn something new, and well, which is, I would say, normal life of anyone that wants to follow let's say, a given technology.
Definitely,
Okay.
like keeping up with
Mhm.
technology nowadays is literally in every industry, every
Mhm.
position in a company has to do or has to keep up with technology no matter what you're doing, definitely.
Yeah.
If you want to be relevant in the market,
Mhm.
you have to be there, right?
Yeah. Yeah.
Okay. Mr. Ivan, can you explain to us what is a point cloud, basically?
Yeah. Point cloud is basically points which have coordinates in space. And basically, we had that before, when we were surveying, but we were collecting the points one by one. And today we have scanners, which will collect millions of points in a very short time. When I say very short time, it's inside a minute, let's say, depending on the scanner you have. And of course, since that makes a lot of points, and when you look at from far away, it looks like a cloud. Basically, this is why we call them point cloud. Each of these points, depending on the instrument, may have some data attached to it. So that makes it a lot more interesting in this case.
Excellent. Thank you so much. Well, now that you have introduced us to the main topic of this podcast, that is point clouds, we want to know how they are used in the mining industry.
In the mining industry, there is many use for point clouds, but we can make that in short. I'll give a short explanation and then detail after that. In short, basically, you want to have the shape of something, and you want to have it with a certain density of points, so that you have a good idea of that shape. So in the mining industry, you will make a point cloud, and that point cloud will enable you to have a better volume calculation of, let's say, an opening, volume and tonnage, of course. Let's say you want to set up an Alimac raise. You'd like to have a more detailed model where you want to do this. Same thing, let's say, for a raise bore. Pumping station, a fuel bay, or any type of installation where you need to make some construction, basically. So you go in there, you make a point cloud, and basically you have a much better idea of what is there. And of course, this helps you plan, see if you have enough room for this and that, and get this to go. Also, the computation of dilution in stopes is another use for point clouds. I think that's one of the most interesting one in there, because it really have a very big impact on your profitability at some point.
Oh, well, that's amazing. And speaking of efficiency and all, like beyond the visualization feature, how does the use of this point clouds improve the efficiency and the accuracy of mining operations in general?
The one thing which is very interesting is scanning is quick. So usually you have some people in production working there, and you need them to move out of the place so that you can make your scan, and there's not too many things basically blocking the scan. So you gain time, basically, because when you scan, you're not there for a long time, and you collect a lot of points. So you also have a better as-built model in there. So that will help you, check some clearance for equipment, or compute your steelwork dimensions. Whenever you build something, you need to bring some steel beams in there and see if that fits in there. Sometimes you have to plan how much grout you need to put somewhere, and So you can have the exact amount of material, and when you set it up, you spend less time fine-tuning and adjusting, basically, because you can already have something that will fit in there. So that makes you very efficient in some ways, in order to plan, make something, set it there, and have it ready to be used. Also, when, let's say, as I was saying, you measure dilution, you have a better idea where that dilution is coming from with a point cloud. So you can correct basically what you do in order to reduce that dilution in there. So there is a data that wasn't available, I would say 30 years from now, even 20 years from now, or that was very long to collect and do. And basically it helps a lot to do things.
Yeah, and that's all we want, like within a mine. You just want to optimize all our resources and also perfect.
Well, our next question would be, what are the sensing instruments that capture point cloud survey data inside the mine? And what is the process to obtain scans of point cloud in mining environments? It's a bit more detailed, but we would really, I think our audience would really enjoy, listening to the details of this.
Okay. You have two categories of scanners, two main categories of scanners. You have fixed scanners that you set up, usually on a tripod, and that you scan around. It will start usually rotating and going around and scanning points. And you have moving scanners that you can walk around or have on rolling equipment, and that you go around. So those are, let's say, two types of scanners. How they scan, there is also two large categories. You have LiDAR and photogrammetry. LiDAR is like a laser. It will send a beam and measure where that beam hit something. So you get X, Y, Z coordinates. Sometimes you'll get some more data, like the reflection and an idea of the surface, basically, which is coming from there. Okay, I'll start with kind of making the difference between mobile and stationary fixed scanners. Fixed scanners are cheaper, and basically you set them up somewhere and they just do the scan. And if you want, let's say, to have more details about an area, you can, of course, place them close to that area. And they are more, I would say, precise than the mobile scanner. And you'll understand why. Because mobile scanner, you take them, you start at one point, and you go around and you scan. And there is a inertial navigation system, same thing as a gyroscope, basically, that measure where that instrument is going. And this is not perfect when you move around, basically, because there is a small error that accumulates with time. And most of the time, you want to start at one point, do your mobile scan, and come back to the same point, because there is a drift, a deviation, basically, with time that accumulates. And when you're looping back on the same point, you have an idea how much drift that you have from the original, and you can correct, basically, the deviation that you have in time. Of course, if you're on surface and you have GPS signal, you don't have that problem. But underground, we don't have the GPS in there, so basically we need to compensate some ways because of it. So this is why, of course, moving scanners are more expensive, but they also have an imprecision that comes with it. Of course, it's not large, but if you want really something precise, better go with a fix. Moving scanners, though, are very interesting because they can reduce the time to make a survey of an area, because you can go around the area and you can fill in all the gaps. Because when you scan something, there can be shadows. Like if there is an object here and my scanner is here, and behind that object, there might be something else. If you scan, you hit there, but you don't see what's behind there. And in a mobile scanner, you can move it around so that it will see behind that shadow. And at that point, you get a more complete point cloud in this case. So this is the main difference between mobile and fixed scanners. LiDAR and photogrammetry. LiDAR is faster because collecting a point is very fast. It goes and collects millions of points in there. But you don't have the color information in this case. Some manufacturer will have a camera that will also look at where the LiDAR is pointing and will give a color according to where it points. So that's what LiDAR is lacking, basically the color. But there is one thing which is very interesting in underground mining is LiDAR doesn't need light, because, of course, there's many places in an underground mine where there's absolutely no light. And basically, if you want to use photogrammetry underground, you will then need a source of light to, make it so that you can have something on the images that you're basically picking up in there. Photogrammetry is also slower in this case. So you have to balance as, do I want to have my geometry quick, or do I want to have photo-like images where I can spot differences, let's say, between two areas? So basically, this is the big difference between LiDAR and photogrammetry in this case. The process is fairly simple. So you get there and you basically set up your instrument, scan, and you move out and you're done. So it's in both cases, it's fairly quick.
Perfect. I mean, like, this is a question that I always like I want it to be present in every mining operation, which is the safety of the employees in general, and now especially that we're talking about point clouds, this means surveyors. So maybe this help as detecting unstable walls, for example. So my question to you is, how do those point clouds contribute to the safety of surveyors?
It's safer work because you don't have to be as close as where you want to pick up the points, basically. You also spend less time there because the more time you spend, let's say, in a freshly mined area, usually, it needs to be supported, but it's a place which hasn't been thoroughly, I would say, made safe. The less time you spend there, the better it is for your health. And also, if you think about it, if you have to spend less time underground, because most of the accident to surveyors will happen, when you're on the field, not in the office. So basically, you're reducing your chances to have an accident there. And basically, production is around, so there will be always moving vehicles in that area. So that's also a factor of safety that you have to take into account. Also, if you take less time, you may fit in between a change of equipment. Let's say the support is done and they're preparing to move in the jumbo, and you will maybe happen to go by when the jumbo is not ready yet to go to the face, and basically you'll be there in a quiet environment and do your scan and come out. So and one thing also for safety is you could make a scan somewhere and go back there, let's say 1 month later, and compare both scans and see if there was ground movement somewhere. And of course, if you see some ground movements in some area of a drift, you say, okay, here that moved a bit, let's say 5 millimeters, so something is unstable there. And of course, you can, at this point, take action to make that safer.
Okay, perfect. Excellent. Well, we were just talking about technology and how all the advancements have an immense impact and have tons of benefits and, well, improving operations. So how, we would like to ask you, how do technological advancements such as drone mapping impact the use of point clouds in the mining industry?
Safer work. Before, when you wanted to, let's say, look at a stope once it was mined, you had to get an instrument in there. And very often, like the CMS instrument was at the end of a long mast that you would bring inside the stope, but you still had to get, close to the brow, which is the edge where you start to enter the stope, and and that makes it unsafe. Even if you're not inside the stope, rocks are falling and some will bounce back and get to you, and of course stopes are not supported, so this happens continuously. Basically, you can hear it sometimes, like continuously thing coming down there. So it was impossible to make a survey, a complete survey of a given stope. There was always shadows because of that technology, and unless you had many openings where you could get into that stope, that was you would get a good picture in there. And basically, having a drone, you can stand back a lot further, and you can send the drone, and the drone can go inside and pick up the whole thing without any shadows in there. And it doesn't take much time. Basically, you need, of course, to set yourself up and then fly the drone inside the stope. So the drones are getting intelligent too. They'll not run into walls even if you ask them to go into walls. So that's getting much easier to use also. So drone mapping is very interesting in a lot of cases.
Thank you so much. I like how everything you're telling us goes back to safety of the personnel and making things more efficient. Like this is what technology is looking for, and we can clearly see it in everything that the mines are starting to implement. So it's very interesting. Thank you.
Well, beyond the safety part, me as a mining engineer, I appreciate that we are getting to this point to work with like in stopes and have to optimize all the mining operation, because it really helps a lot during the whole process. So I was wondering, like, if you could mention a real life example or a case of a successful implementation of point clouds that you had in a mining industry.
Yeah. That one was like mind opening. Basically, it was like, whoa, okay, this is great. We have a client. They have a mining area which they are working in, and they're looking at replacing equipment. So they're kind of, okay, which equipment should we choose? And of course, there's even inside a supplier, they have various type of equipment with various dimensions, and you know that selecting that equipment is multi-million dollars investment in this case. You know, it's costly, let's face it. So basically it said, okay, we have that mining area and we're not sure if that equipment can travel to all of those drifts. So basically they went and did a point cloud survey of all the travel ways in that area. And with the software, we could input basically the dimensions of the equipment and then check where that equipment can go and not hit the walls or the back of the stope. And basically you would say, okay, that equipment will fit. It will be able, you know, to turn here, use that drift, and yeah, and you can even color code basically the point clouds where basically that equipment may hit or there might be some problem. So at some point you may take the decision, okay, we cannot choose that equipment, or if we choose that equipment, we may have to do a little bit of secondary blasting, you know, make that increase that drift here, here, and here in order for that equipment to safely go around some part of the mine. So you're making a decision which is measured here instead of kind of, yeah, it's going to fit. Well, that one fits here, so this one should fit, or you know, having kind of a ballpark thinking about it, and it's yes, it does fit. No, it doesn't. It might fit by that much. You have all the numbers basically to take the decision, and then you can, you know, work out the economics of this. Okay, that equipment is this price, but I may have to do that much rehabilitation in my drift in order to make it fit. So that was like, oh, hey, this is a great tool.
Excellent. Thank you so much for this example. Well, until now, we have focused on the benefits of point clouds, but we would also like to know what are some of the challenges and limitations of using point clouds? Yeah, well, of course, in the mining industry.
A point cloud scanner doesn't have the precision of a total station. So if you think that you're going to replace your survey total station with a point cloud scanner, forget about it. There is no way you can, let's say you have 1 kilometer of drift to do, and you have a specific target to reach, and trying to do this with multiple point clouds together, and you know, making them to stitch together and saying, okay, this is where we're going, and know with precision where you are going. No, you need to have a total, still to have a total station to do that type of work and get the right alignment to know where you want to go. The size of data is also a challenge, because you're going to get with huge files, and very often people will just use their scanner at maximum density of points, which very often is an error. You don't need that much points basically for what you want to do, but you end up with tons of files which are very large, and then IT is going to complain that you're taking all the disk space, and then your software will start to complain of the size of the data. And whenever you want to make a computation of of those large file, it will take more time, and you know, it's that's something which is a challenge with point clouds. Of course, there is software to take care of this, and you can manage that in some other ways, but it's always a challenge. There is noise into point clouds. Noise is, let's say you have a flat something really flat in here, and you take a scan of that flat place. Not all the points will be on that flat thing. There will be points on and off, sometimes by, let's say, a centimeters of that flat surface. So it's not exact. And the problem is manufacturers want to collect the points as fast as possible, and that they'll, in this case, they will start to, lack a bit of precision in this case. So thinking that a point cloud is perfect and exact, no, there's a little bit of fuzz into point clouds. And of course, when you take a point cloud, you need to georeference it. And georeferencing, it means having it in space at its exact location. And this is where people will often overlook that part, where you need to be able to locate exactly where that point cloud is. So you need reference points into that point cloud that you can connect to actual surveyed point, which were surveyed, of course, with another way. So that can be something that is overlooked in making point clouds. This is something you need to do before basically taking the point cloud and making sure that it works. Sometimes the let's say you have some water and you are able to pick points on that water that will help you make it level, so that it's perfectly horizontal, because sometimes you'll have a point cloud, but it will be a bit of at an angle. But if you have that little bit of water that your scanner can take, you can just, okay, this is my flat way to have my point cloud. Then you only have to rotate it and move it into the right spot in this case. Of course, as I said, fitting multiple point clouds together, there are software to do this, but stitching that together is sometimes difficult, depending where your scanner was located and if there are enough command points between the point clouds. Also, the distance will have an impact. So sometimes you'll have inside a point cloud areas which are densely measured, but areas when you're moving further away where there's not that many points, and those parts might be useless actually. And you can basically remove that from your scan. Of course, darkness can be a problem. Sometimes, when a surface is very dark and doesn't reflect anything, even the lidar won't be able to pick up points in some areas. Water can be a problem, because sometimes it's like if you're looking something in a mirror, you see it somewhere, but in fact, it's somewhere else. So sometimes when you measure and it hits water, it will give you a distance, and that distance is wrong basically, and you get points which are scattered here and there. So there is always some preparation you can do before basically doing your scan that will help you having a good quality scan. Of course, removing objects which are in the way, and sometimes you even have people walking around, and you get, okay, yeah, Joe was there. How do I remove Joe from my point cloud? And it's kind of, Joe, you should have went elsewhere. But that's always kind of operational problems, I would say.
Absolutely. Water has always been a problem in underground mining, but I was actually triggered when you talked about, when we say point clouds, we actually talk about massive files, and they cannot always be effectively handled by softwares. We have to go through the many daily operations we do as engineers in softwares, like 3D modeling, and then we have to optimize the compute the resources, block modeling and all. So we always tend to have solutions And that's why I'm going to ask about the Promise solution. So my question is, what is Provis, and how does Provis solve the challenges of working with the point clouds?
Yes, and so Provis is one of our newest products, and basically it's a web-based program. So it's not something that you have to install actually into your computer. It's all web-based, so you can use it almost anywhere on any computer. Of course, it will handle a lot of point with ease since it's cloud-based. The computation basically is done on cloud computers, which will free up. Well, most of the computation will be done on a cloud computer, which will free up your local computer, and you will not be dependent on, let's say, the processor you are using in there to do those operations. And of course, when you're using cloud computers, you can say, okay, I have this task to do, and you can distribute it to many computers, which will speed up something, let's say, that takes 2 hours onto your own computer. That will take maybe 20 seconds on a cloud computer, because you can attribute so much processing power to this. So you're getting speed in this case. And also, since all the files are web-based, you are actually freeing up some space on your local server. So your IT guy will not be and complaining about your files, and then you have to delete basically those files which you may need in the future, and all of that. So we can store basically a very large amount of points on cloud storage for a very decent price, basically. And that way, basically, you don't have to upgrade basically your local computer, your local servers, your local storage in this case. So that's kind of well, everybody wants to hear that, basically. So that's always very helpful for everyone in there. Also, you can handle a lot of points before you get to the limit of Provis. It's you can bring in the gold version, you can bring probably billion of points before you start to see some I would say performance degradation in this case.
Excellent. Well, I mean, I think everything you told us until now, it's sounds of like Provis has so much power, and definitely, well, as you were just telling us, one of the main challenges of point clouds is these amazingly huge files that even when they are super useful, they still have this issue. What you said, the IT guys want to kill the mining engineers for giving them all the trouble. So can you tell us more about like the functions of Provis, please?
Yeah. Well, Provis can handle various types of point cloud files types. So the point LAS, point E57, XYZ, and so on. I think there is 10 or 12 type of files. And if it's not in there, we'll add it, no problem. Once you have that in Provis, you can do point cloud reduction in order, to bring the points to a more manageable size points. You can modify the view of the points. You can color them if you have some intensity or RGB code, which are red, green, and blue codes. So you can display that by color. Let's say if you want to spot some features according to colors. You can, of course, filter points by coordinates. But one thing which is very interesting is you can make a 3D model with the points and send this to a CAD program like AutoCAD. which ProMine uses, of course. And creating that 3D model, of course, doesn't take much time, which is very interesting. Of course, once you have the 3D model, you can also compute volume and tonnage of the opening that you've been surveying, which is ultimately, basically, this is what you want. This is what has value into a point cloud, basically, because the point cloud itself, yeah, it's nice, but you want to have the numbers, the properties that goes with the point cloud. Like when I was talking about the drift, what had value is, okay, where my equipment can go. And this is the information that has value. So a point cloud by itself, yes, it's useful, but when you can extract data and use it, basically, to whatever you want to need, this is where the value is located. And Provis help you get this value from the point cloud.
Well, thank you, Mr. Ivan. We're looking forward to more with this, and that's why I'm going to ask you about the future trends and the advancements in the use of point clouds.
The future trends is well, it goes in various directions, but automated point collection basically is one of them. Basically, you can mount basically a scanner on an equipment that you drive around the mine, and basically you could scan points as the equipment is going around. So let's say you have a shift boss which is going around to different places. He could basically park his equipment near the spot where to collect points and just press a button and do a scan, a quick scan there. And whenever he moves to other places, he could, collect the points without having to kind of have a fancy setup or fancy thing. So, and this can be downloaded automatically whenever he gets into a location where there is some Wi-Fi. Also, intelligent drone flying system. When you fly a drone underground, you have a given distance, you can control it basically. And at some point, let's say you turn one corner, it's still okay. If you want to turn a second corner, then the radio transmission doesn't work. And this is something which is actually into development. Is you send a drone and it will just go and follow any opening, and at some point come back to the base, backtrack to the base. So you can get a lot more distance and basically collect a lot more data without having to worry about losing contact with your drone. So that's kind of the practical part of doing a point cloud. The other part is when we get point clouds, very often we want to sort points by different things. Like when you survey a drift, there will be, let's say, a ventilation tube in there, and you'd like to remove that ventilation tube or electrical cables or pipes, basically, which are in there, and basically getting the intelligent point classification and object recognition also is something which we are planning to. Well, it's kind of started right now, but it'll be probably ready in a few months from now, so that you can clean up and keep only the parts that you want and split the other part into different things, basically getting the data which is of interest. Creation of simplified models from those points also. We already have tools that do this, but we want to improve them to better reflect basically what is needed by whoever wants to use that point cloud, because depending on if you're doing construction work or you just want to have a fairly simple 3D model of a drift, you'll work differently and you'll want to have a different density. So creating simplified models is also something which is in the planning.
Excellent.
Yeah, we're looking forward to this.
Thank you so much. Well, now I just want to say that we are almost finished with this episode, so we want to remind everyone that is watching us to leave your questions on the question section on Zoom, or if you're watching us on YouTube, you can just send a comment there and we will read your questions at the end. Well, we have one last question, and this question is, how does the use of point clouds contribute to the sustainability and the responsible development of mine operations?
Many ways. Well, you're using less time to do things. So you're not, you're kind of being more productive with the same resources. Of course, you reduce and you have a better use of material. Let's say you plan an electrical station and you want to build that electrical station. You're not going to make, let's say, 5 cubic meters too much of cement that you need to throw somewhere when you construct this. So you have also a better use of material, but you're creating less waste material. So if you, let's say, you're using steel in there, you don't have to cut and throw away some parts, little parts here and there. So, you have a better planning. So that's always good. Mining dilution. If you reduce mining dilution, it means that wherever you store your waste, let's say on stockpile somewhere, you can say, okay, my stockpile is going to reduce, let's say, by 10%. So your environmental impact is diminished that way. But there is one thing which is also very important in there, because every time you move 1 ton, you consume energy in a different ways. It can be electricity, it can be DSL, all kinds of energy is needed to move those tons. And basically, if you reduce dilution, you reduce the number of tons you're moving around, and basically waste material that you need to handle. Sometimes, those waste material will create acid drainage that you need to protect the environment because of that acid drainage. So that helps a lot in many ways, basically, to mine only the ore and have as much waste staying there, basically, instead of being handled and going through the process, the mining process.
Excellent. Thank you so much for your answer. Well, now we have a question on our YouTube channel, so I'm going to read it for you to answer, Mr. Ivan. The question is, would point clouds be more useful in underground or open pit mines?
It's useful in both. That's for sure. Open pit doesn't need, I would say, the detail of underground, because in open pit you have a very good idea what's going on, and usually you're working on larger scale, and basically in open pit, let's say 1,000 tons difference is not, well, depends on the operation, it's not that much. Underground, 1,000 ton difference is a catastrophe. So it's always underground need a more detailed view. One thing which helps also in open pit is very often if you can see the difference between the ore and the waste, you don't need to be that precise, let's say, in your blasting, because of the guy operating the shovel will be able to, pick up the ore and dump it into the truck. And sometimes it'll plan his shoveling like, okay, I'm making a bunch of trucks of ore, and okay, I left the waste that was there, and I'll just shovel it up and send that other truck to waste. So in this case, having a very good scan and having an idea where ore and waste is located in open pit, in some cases, it's doesn't make that much of a difference. So underground, you don't see much, and basically you need to have that good idea where you're going and how this is done. Also, when you do something underground, it's a lot of trouble. If, let's say, you have a piece of equipment that breaks on the surface, the mechanic can easily go there with all the everything he needs to repair that equipment very easily, let's say inside half an hour, if it's something fairly simple. Underground, oh well, you need to travel down the ramp sometimes for an hour, or go down through the shaft, and sometimes if it's large pieces, you need to plan that moving through the shaft and then go to where the equipment is located, and that makes it a bit more tricky, basically, underground. And of course, if you build something and you're missing something underground, okay, we need to bring that, I don't know, that 20-foot steel beam down there, and it's kind of, ooh, okay, yeah, that's something. Like in surface, it's like, oh, bring the flatbed. That's nothing.
That's actually enlightening, because to me, I was more thinking that underground mining is more challenging than open pits. Like there are water, there are darkness. That's for sure. We talked about for like processes of scanning. So I was more thinking that, yeah, it would be much helpful in underground. But you're absolutely right. Thank you so much. So, do you have anything more to add, or that's fine?
No, all good. I guess if you want to go point cloud, that's the way of the future. So
yeah, indeed.
Yeah. That's definitely a good conclusion. We don't have any more questions, so
excellent.
Thank you.
Well, we have arrived to the end of our episode. We would like to thank you, Mr. Ivan, for your time and for sharing all those precious informations with us. And we also thank all our attendees for their time and contribution, for their question. And finally, like if you have any other questions or want to take a closer look at Provis, just please do not hesitate to contact us, and we will make that happen.
Thank you, Ma. Well, finally, we want to remind you to please follow us on our social media. We have LinkedIn, Facebook, YouTube, Instagram. There you will find more information about our software and our different solutions. And of course, our events. We have almost on a monthly basis a different course, and podcasts, always podcasts. So please, you're invited to come. And well, having said that, we thank Mr. Van, and see you in next month on the mining experience.
Thank you.
Thank you, everyone.
Bye.